Okay, so when we're graphing, remember your transformations are, I just put the general formula at the top right here. So anything outside the brackets, remember, affects your y coordinate, so it's a vertical transformation. So A and B are vertical transformations, A being the vertical stretch and B being the vertical shift. So in trigonometry, we call the vertical stretch the amplitude. So in this question, the amplitude is 3, which is going to vertically stretch it by 3. And then there is no vertical shift in this question. And then anything inside the function, so inside the brackets would be horizontal transformations. And again, anything multiplied will be a stretch or a compression. Anything added or subtracted will be a shift. And x always is affected in the opposite way than what is indicated in the equation. Okay, so C is a horizontal stretch or compression, and so what it does is change the period. So a normal period is 2 pi, but that will be affected in the inverse way by C, so divided by C. So in this case, C is 2, so that horizontal period is now, instead of 2 pi, it will be divided by 2, so now it's pi. So the 2 basically means that we're compressing it by a half, and we'll get the cycle in twice, right? 2 times in the normal 2 pi period. That's what that 2 means. And then we would ask for mapping notation. So the mapping notation tells us what is going to happen to the x coordinate and what's going to happen to the y. So the x, the 2, as I said, will be the inverse, so it'll be 1/2. And then the 3 directly affects the y. And then we would list our mapping notation, keeping in mind it's cosine. So cosine starts at the top, and then it goes to the middle, and then it goes down to the bottom, and then back to the middle, and then completed at the top. And so we're just going to apply these transformations to these points. So these are the critical points that give the graph its shape. So every x I'm going to multiply by a half. So a half times 0, and then 3 times 1. And then it'll be a half times pi over 2, so pi over 4. And then 3 times 0, and then a half times pi. And then a half times 3 pi over 2 is 3 pi over 4. And then a half of 2 pi is pi. So the nice thing about mapping notation is that you can see the points that you're going to graph before you actually figure out your scales on your axes. So I can see that my vertical scale needs to go up to 3, so I'll put that on there, and then down to -3. And then my x coordinates are increasing every pi over 4. So I like to always draw 2 cycles. I can do 2 cycles to the right, or I can do 1 to the right, 1 to the left. Either way is fine, as long as you get in 2 complete cycles. So I'm just going to draw in this one and then repeat it. So I'm going to divide my, I don't need to go to 2 pi because my period ends at pi anyway. So I might go every 2 squares as pi over 4. And that will get me to pi. And then I'll do the same in the negative direction. So you want to make sure that you label your scales. Don't put blank scales, right? You have to have some numbers so I can see what you're dividing it up by. And I did one, I'm going to do 1 cycle to the right, and then I'm going to do 1 in the negative direction. So I'm just going to repeat it. So my graph starts at the top of the cycle at 3. At pi over 4, it goes down to 0. Pi over 2, it goes down to -3. Back to 0, and then back to the top. So make sure that your graph is decently spread out. It's not some tiny little graph that's hard to read. And then I would just, once I get 1 cycle in, I'll just continue. So I can see that every 2 squares, or pi over 4, I get a new point. So starting at the top, I would go back to the middle, back to the bottom, back to the middle, back to the top. And there's 2 cycles. Okay, so I can, the nice thing about mapping notation also is that when I'm marking it, I can see what points you were trying to plot. Even if your graph is incorrect, I can still see, well, they had the points correct, so, you know, the graph, maybe they made a slight error in that, but that's fine. Okay, if you just give me the graph without the points and it's completely wrong, then I can't really give you much value because I don't know what you were trying to plot. Okay, so make sure that everything is on the graph. You get numbers on both axes. And then I would just kind of check my graph to make sure it corresponds to the equation. So looking at my graph, I can see that the amplitude is 3. So that looks correct. And I can see that I start and end in pi. So that is correct. So my graph looks like the equation indicates. All right. So this one is a sine curve. The amplitude, there is no number in front of sine, but there is a negative sign. So the leading coefficient is -1, but remember that the amplitude is always a positive value. It cannot be a negative because it is a distance. So the amplitude is 1, and then there is a vertical reflection. So that's what the negative is. Okay. So just make sure that you don't put amplitude as -1 because the amplitude can never be negative. The period is stretched. So C is a half. So 2 pi times a half or divided by a half is the same as multiplied by 2, right, by the reciprocal. So the period is 4 pi. And it has a vertical shift of 3 units up. Okay, so I'll do my mapping notation. This time it is sine. So the 1/2, the horizontal compression is going to double my x, and then the y will be negative, that's the reflection, and then added 3. And then we'll write down our critical points. So sine starts at 0, 0, and then it goes up to the top, back to the middle, down to the bottom, and then back to the middle. Okay, and then we'll apply this mapping notation to these points. So we're going to double the x, and then the y will be -y plus 3. Then we have pi over 2 times 2 is just pi. And then -1 plus 3 is 2. Then we have 2 pi and 3. So I can see that my x is going up by pi. 3 pi over 2 times 2 is 3 pi. Once you see a pattern, it's pretty easy to make sure that you get the correct answer. Just be careful with negative signs. So -y, and if y is -1, that's a +1. So it goes up to 4. And then 4 pi and 3. So I can see that to get through one cycle, I have to go from 0 to 4 pi. So when I'm doing my scale on my axes, I'm going to go to 4 pi. 1, 2, 3, 4 pi. So make sure I label that, and then I'm going to go the same to the left to -4 pi. And then my vertical has to go maximum of 4 and a minimum of 2, so I can fit that on here. So 2 and then 4, the middle being at 3. And now I'm ready to just plot my points. So it starts at 0, 3. At pi, it goes down to 2. 2 pi, it goes back to 3. 3 pi, it goes maximum of 4, and then back to. So there's one cycle. And then I'll just repeat going the other way. So every pi, I'm going to get a new point. So then I would be going up to the maximum, back to the middle, down to the bottom, back to the middle. And there's a cycle going to the left. And then I just check. The middle is at 3. So that's my vertical shift. The amplitude is 1, so that looks correct. The period is 4 pi. It starts and ends at 4 pi, so that is correct. And then it has been reflected. So my cosine or my sine, instead of starting and going uphill, it's starting and going downhill. So that is indicating the reflection. Okay, any questions on the first two graphs? Have a look here. Okay, so here's the next one. So this has an amplitude of 1, right? There's a 1 at the front here that is not written. The period is compressed by 3, right? So it's 2 pi over 3. And this one has a phase shift. That is inside the bracket. It's pi over 6. And then you need to indicate whether it's right or left. This one is right. And then there's no vertical shift. So my mapping notation, the 3 would make sure that x is divided by 3 or multiplied by a third, however you want to write that. And then minus pi over 6 would become plus pi over 6. And then there's nothing happening to the y, right? There are no transformations applied to the y. There's no number at the beginning, and there's no number at the end. So it is cosine. So starting at the top. Okay, so we're going to multiply the x by a third or divide by 3, however you want to look at that, and then add pi over 6. So a third of 0 plus pi over 6 is pi over 6, and then y stays the same. And then we have 1/3 times pi over 2 is pi over 6, and then we're going to add pi over 6, so that's 2 pi over 6, which reduces to pi over 3. If you want to leave it as 2 pi over 6, that's fine. It might make it easier to graph. Then we have 1/3 times pi is pi over 3. And we have to add that to pi over 6, so you need a common denominator. Right, so you've got pi over 3 plus pi over 6. So we're going to change pi over 3 to 2 pi over 6, which gives us 3 pi over 6. So maybe I'll leave it as pi over 6 just because it's easier to graph. Or you can reduce it. So this was 2. This is 3. So I can see already that it's going up by pi over 6, right? I can already see that. So I would expect the next one to be 4 pi over 6 and the last one to be 5 pi over 6. So just to double check, 3 pi over 2 times 3, 1/3 is 3 pi over 6 plus pi over 6 is 4 pi over 6. And then 1/3 times 2 pi is 2 pi over 3. Common denominator, I would change that to 4 pi over 6 plus pi over 6 is 5 pi over 6. So I can see that I need to divide my x-axis by pi over 6. Okay, so I might say every square is pi over 6, or maybe I'll be able to fit in 2 squares as pi over 6. Let's see. 1, 2, 3, 4, 5, 6. So I'm going to make that pi. So this is 1 pi over 6. This is 2. 3 pi over 6 is the same as pi over 2. I would like you to put in all the numbers. I can't fit it in very well just because of my smartboard. So I'll just leave it as that. So we've got 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. So 1, 2, 3. Okay, so every 2 squares is pi over 6, and that spreads it out nicely. So I can fit in a cycle on each side, and I'm not squishing it all in. If you want to leave it as 6, like I said, that's fine. Or you can reduce them. So you could reduce 2 pi over 6 to pi over 3. That's up to you. And then we are going up to 1 and down to -1. So we can plot our points, pi over 6 and 1. 2 is 0, 3 is -1, 4 is 0, and 5 is 1. So there's one cycle. And then I would just continue it going left. So back to the middle, down to the bottom, back to the middle, back to the top. So there's another cycle. So I've got it in 2 cycles. The middle of the graph is 0. So that is correct. My amplitude is 1. That is correct. My period is 2 pi over 3. So from here to here is 2 pi over 3. And then I have the top has shifted right. You can see the top's normally here and it's shifted right pi over 6. So that looks correct. Okay, so as I mentioned, make sure that you write your mapping notation and your critical points so at least I know what you're trying to graph. Whether you have it in reduced form or not, that's entirely up to you. Okay, I'm going to get you guys to try one. So all I want you to do right now is try to write down the properties. So amplitude, period, phase shift, vertical shift. There's a bracket here. And then do your mapping notation and your 5 points. Okay, I'm just going to mute myself for a quick second to do my attendance. Okay, let's see. All right, let's see how we're doing on this question. All right, so the amplitude is just 1. It has a vertical reflection. The period is going to be pi, right? So 2 pi divided by c would be 2 pi divided by 2, so just pi. It has a phase shift of pi over 4, which is going to the left, and it has a vertical shift of down 1. Okay, so there's 4 transformations here. And so my mapping notation would be x will be half, right? So the inverse of 2. And then plus pi over 4 would be minus pi over 4. And then my vertical transformations are a vertical reflection and then a vertical shift down. It is sine. So we'll write out the critical points for sine. Oops, did cosine there. That's incorrect. -1 and 0. Okay, so let's apply these transformations to these points. So half of 0 is 0 minus pi over 4, and then minus 0 minus 1 is minus 1. Okay, we have a half of pi over, a half times pi over 2 is pi over 4, minus pi over 4 is 0. And then -1 minus 1 is minus 2. Then we have a half of pi is pi over 2, minus pi over 4 is pi over 4, and then -1. And then we have a half of 3 pi over 2 is 3 pi over 4, minus pi over 4 is 2 pi over 4. Or if you want to put pi over 2, that's fine if you reduce it. And then 0. And then a half of 2 pi is pi, minus pi over 4 is 3 pi over 4, and -1. Okay, so I can see my vertical goes maximum of 0, minimum of -2. So I'm just going to spread that out a little bit. And then my horizontal axis, well, my smallest increment is quarters. So I'm going to divide by pi over 4. So I might make, let's see, 1, 2, 3, 4. I'll make that pi. So each of these is pi over 4. And then I'll do the same to the left. 1, 2, 3, 4. So it's nicely spread out. Right? I don't have everything squished together. It's easy to read. And then we'll just plot the points. So negative pi over 4 and -1, 0 and -2. Pi over 4, -1. pi over 2 is 0, and 3 is back. So there's one cycle. And then I'll just repeat that to the left. So back to the top, back to the middle, down to the bottom. And there is 2 cycles. Okay, so it's not that hard. Just make sure that you use the correct trig ratio. Make sure that you're doing sine or cosine. You will not be asked to transform any of tangent or any of the reciprocal ratios. Okay, I'm just going to do one graphing because some people might be there by now. So you will also be asked to write an equation. Given a graph. And we're going to write it in terms of sine theta and cosine theta. Okay, so when you are doing the equation, I would follow these steps. So number 1, I would find the middle, right? That sinusoidal axis. So where is the middle of the graph? If you would like a formula, the middle is the average between the top and the bottom. So we're going to add the top and the bottom, so the max and min, and we're going to divide by 2. All right, so the maximum is 3, the minimum is -3, and then we're going to divide by 2, so that gives us 0. So that starts us off. Where is the middle or the sinusoidal axis? Okay, and keep in mind that this is also your vertical shift, right? The vertical shift is normally, the graph is normally at middle. So if it is shifted up or down, then that middle will be shifted up or down. So this has no vertical shift because the middle is at 0, which is where it normally is. Okay. Second thing I would do is the amplitude. You can do that 2 ways. You can read off the graph. Once we know where the middle is, then we can just count. Right, so I can say, okay, the middle is 0, the top is 1, 2, 3, the bottom is 1, 2, 3, so I can see that the amplitude is 3. Or if you're a formula kind of person, because some people like formulas, you can find the difference between the maximum and the minimum and divide by 2. So the difference, the maximum is 3, the minimum is -3, the difference would be 6 divided by 2 is 3. Okay, so if you like to have a formula for the amplitude, it would be the top minus the bottom. Okay, so that's my A, amplitude, and that's my B, vertical shift. Right? Okay, the next thing I would do is find the horizontal stretch or compression. So remember that the period is normally 2 pi, and that gets compressed or stretched by the C value. So we could rearrange for C to find the normal period of 2 pi divided by the period of the graph. Okay, so if I want to find C, I'll just reverse that operation and I'll take the normal 2 pi period and I'll divide it as the period of this graph to see what that ratio is. So looking at the graph, remember you can start and stop wherever you want. You want to sort of see what's obvious. I can see that the period is pi. You don't need to have every square labeled. I can clearly see that 4 squares, right? I'm just counting 1, 2, 3, 4. That's pi. So I know every square is pi over 4. So even though it's not indicated, I know that 4 squares is pi, therefore each square is pi over 4. Okay? So I can easily see that to start at the bottom and end at the back to the bottom, the period is pi. Right? So whatever is most convenient to read to find the period. And so C will be 2 pi divided by the period of this graph, which is pi. And so C is 2. Okay, so my horizontal compression C is 2. So keep in mind that we are trying to find this equation. So we have found A, B, and C. Okay, that will be the same regardless of whether it's sine or cosine. That will not change. So we're going to do one version as sine. The amplitude was 3. C is 2. And B is 0. So I don't really need to write that. So that is going to be the same whether it's sine or cosine. It's going to have a vertical shift of 3, it's going to have a horizontal compression of a half, and it's not shifted up or down. The difference between sine and cosine is where it starts. Okay, so remember that a sine curve without any transformation starts at 0, 0. So when I look at this graph, normally the sine curve starts here. Now it starts here, right? So that starting point 0, 0 has now shifted to the right. So here is the sine curve. This is what a sine curve normally looks like. And I can see it shifted to the right. How much to the right? Well, this is pi over 4, right? Because I know every square is pi over 4. So if I'm writing the equation for sine, my x has been shifted to the right, pi over 4. If I'm doing cosine, so I'm just going to erase this. So cosine, without any transformation, looks like this and starts at the top. So normally it starts at the top. Now here's the top, right? So here's my cosine curve. So that top has been shifted, that starting point has been shifted to the right. How much? Well, this is pi over 2. Okay, so remember graphs are always symmetrical. So the starting point for cosine, well, this point here is halfway between 0 and pi. So pi over 2, it's 2 squares, and we know each square is pi over 4. So the beginning of cosine has been shifted to the right, pi over 2. So that's the only difference, okay? There is no other difference between sine and cosine except for the horizontal shift. The third option, and there is another option. My third option is to do cosine with a reflection. So normally cosine starts here. I could reflect it so it's down here. And so this is cosine that is reflected vertically, so it's just been flipped over. So if I do a vertical reflection, I don't need to do a horizontal shift because the starting point has just been flipped over, it hasn't been moved. Okay, so another option would be cosine reflected with no horizontal shift, and I don't need this 0. Right, so that's another option. Remember, there's lots of options because it's a continuous function and it repeats. So I went to the right for my phase shift. I could go to the left, right? I could start cosine here and say my graph went to the left. I could start sine here and say my graph went to the left. Those would be correct as well. It does not matter which way you go, but generally we go to the right in the positive direction before we go to the left. Okay, that's just usually what we do. Going to the left is not wrong. It's just that normally we go to the right. And you can also do the reflection. So when we start to do word problems, going to the left sometimes doesn't make sense, especially if we're measuring time. Like we're doing a Ferris wheel question, time always goes forward. So it wouldn't make sense to go left. It would always make sense to go right. Okay, but we'll look at more of those later on. But that will get you started if you are doing writing equations and you've finished all the graphing. Okay, are there any questions? I know that was a bit long. Okay, so tomorrow is a work period.